I'm a professional biologist myself. I've been involved with Pigeon Lake since the start of my career, way back. After I left the Alberta Lake Management Society and was a past president of our Lake Management Society as well, and worked with Ron. We started the Lake Watch program way back in the mid-90s, and that program is something that we're super proud of, continuing to evolve now. But Pigeon Lake was one of my lakes back then, and we've done caffeine analysis. We wrote a state of the watershed report, and have been working with the Pigeon Lake groups, several Pigeon Lake groups over the past few years. So I wanted to present Pigeon Lake by the numbers and groundwater overview. I'm presenting the groundwater overview of a study that the Worley Parsons folks had done in 2000 and, actually the publication date is 2010, but we worked on that from 2008, 9, and 10. This is back when Equality had office space in the same building, so we worked quite closely with the folks at Worley Parsons. Unfortunately, all the original authors from that document are no longer with Worley Parsons or in the country. And when we had asked them to speak to it, they weren't really that available to be able to do so. So I'm going to speak to that report a little bit, but that was one of the documents that was circulated around everybody in the meeting preamble that Aaron had sent around last week. So Pigeon Lake background, some of the characteristics of the climate, especially for some of our American visitors, get a sense of what's going on in our Alberta lakes and some of the issues that we have here. Surface water quality concerns, some of the monitoring initiatives, and Brad is here from OMS. Erin, I believe, is meeting with the Environment Minister right now, and she sends her regrets, and I think she's going to be here this afternoon. Is that correct as well? So that's great. We'll learn about some of the things that her and Chris have been up to with the OMS water quality monitoring and the nutrient budget there. Next steps, watershed management planning, potential in-lake control methods for algal blooms, and yes, the whole purpose of this workshop, as Al had mentioned, we are looking for the in-lake piece here specifically today only. So we're not looking at all the watershed things that can be done, restricting pest or restricting fertilizer use, those sort of things. We're looking at specific in-lake treatments, whether they be chemical, physical, or biological. So some of the workshop goals, what's a win for us today? Where do we want to go with this? What's a win going to look like? And then the groundwater overview, we'll talk about the wells, the bedrock geology, systems and yield quality. And again, we've introduced most of our guest speakers, and that frames out most of our day today. And tomorrow we'll get into specifically some of those treatment techniques. So by the numbers, elevation of the lake, the surface area, the drainage basin. Those of you good in math will realize that we have a very small drainage basin, the area of the lake, but a surprisingly low water yield. So it results in a residence time in the lake of over 100 years. So that's probably going to be one of the largest impedances for us having a big change in the lake. Even if we started pouring distilled water in the lake starting tomorrow, it's going to take 100 years for that lake to flush, and who knows how long it might take for the sediments to exhaust of phosphorus from the substantial internal loading that we're getting from the sediment load there. Very heavily used, very well loved, sewage inputs, dust from atmosphere, all those sort of inputs are some of the issues there. So again, small drainage area, several small intermittent streams to the north and northwest that drain via Pigeon Lake Creek into the Battle River. It has a low annual inflow and that long residence time. Like most of our central Alberta lakes, it's well buffered, alkaline water with relatively stable temperatures and dissolved oxygen profiles throughout the water column. Large size and shallow depth results in mixing of the water column due to wind. The lake experiences prevailing northwesterly winds, which typically range between 10 to 25 kilometers an hour through the open water season. So the sort of classic limnological term for that is fetch, which results in this lake being very well mixed. Its shallow nature and its very well mixed nature results in it being weakly stratified, if stratified hardly at all in the summertime. Which is going to be another piece in our puzzle in terms of how we're going to be able to treat. You've got a lake that's weakly stratified. It's going to have sets up certain challenges for us if we're going to be adding certain chemical amendments or approaches like that. It's considered very eutrophic, receiving the majority of the external nutrients from land use activities from the watershed. Again, we've got this interesting situation in central Alberta lakes where our lakes are largely loaded from internal loads from the sediments. Lake sediments consist primarily of clay and silt with abundant concentrations of iron, aluminum, and calcium. And I know Dr. Schindler has done a lot of experimental work throughout the province, adding iron in some of our lakes and trying to use that as a complexing and helping to precipitate more phosphorus. Probably not going to be the approach we want to chase here in Pigeon Lake. We're in the North Saskatchewan Watershed in the Battle Sub-Basin, and this comes from the North Saskatchewan Watershed Alliance's. We don't have anybody for your NSWA yet. We've got Melissa Logan and Dave True. We're both scheduled to be here today. So I'm sure they'll be along, but those are the folks who are the Watershed Management Planning and Advisory Council for this basin. So, and of course Dave True also comes from Alberta Environment. He's been the NSWA manager for about 5 years now. He's also a very strong knowledgeist, so looking forward to having his participation here too. Had some recent bathymetric data collected on the lake. About 25% of the surface area of the lake is taken up by the littoral zone, so depths less than 4.5 meters. Majority of the surface area ranges between 5 to 7 meters deep, as indicated in the green there. So this is one of the things I wanted my staff to come up with, was the percentages and depths of the lake so that we can get a sense of how much deep water that we're actually dealing with. And obviously this is a big issue for the fisheries as well. And I understand that there's quite a squeeze at Pigeon Lake because of the thermal issues from the bottom, where you've got water temperatures that are cold enough and oxygen concentrations that are adequate enough for fish. And so we see frequent fish kills on the lake every year. We had a very strong fish kill last year. I know they were pitchforking fish out daily. There was daily pickup. Pitchfork the dead fish off your beach and put them out front, and they were doing daily pickups of that. The lake was closed, I believe, for 96 days last year for a fecal coliform or algal postings. Yes, sir.
You don't close lakes.
You don't close lakes?
It was
advised. Okay. Right. All sorts of interesting liability around actually closing lakes, so thank you for the correction. It was recommended not be used. So when you consider that the ice is only off a prairie lake for maybe 110 or 120 days per year, that's a substantial amount of your recreational time on the lake. So you can imagine why folks with very expensive properties, or even those without very expensive properties, are pretty upset that more than 3/4 of the time that they go out there, it's recommended that you don't use the lake where there's some nasty algal bloom going on. We've got a pretty good handle on land cover and land use around the lake. Again, this is some older data from the atlas, but 50% forest cover, 46% cleared for agriculture, 4% cottage and residential use. Fairly substantial cottage development most of the way around the lake, and only the south side of the lake is actually on a sewage line. Sorry, north side, thank you, is on a sewage line on the north side. There's a land cover map as well. We've got a good handle on that, and of course with all the great GIS products that there are, we can do all sorts of interesting analyses with land use, land cover, how hard working is the landscape, what kind of cover we're looking on there. I have lots of great conversations with folks like Tracy Scott around what sort of runoff coefficients you would expect from landscapes like this. Historical weather data, we are at the 100th meridian where the Great Plains begin. If you know the Tragically Hip song, but net evapotranspiration exceeds net evaporation, and so we're dry. And so we've got a water deficit situation here. We don't get a whole lot of rain to start with, lots of snow, and cold and dry. Some weather data from 2013, mean average temperature 2.9 degrees C, max temperature 32 degrees C, minimum temperature 32 degrees C, annual precipitation 611 millimeters. Probably one of the best opportunities for us being in a cold climate is to do an awful lot of our activities on winter ice cover. Ice is a great stable platform to work on. We can be poking holes in the ice and doing some either chemical amendments during that time when it may be stratified as well. I've always looked at, I've always kind of in the back of my mind had thought that that ice cover period might be the best time to be approaching the lake for, especially if we're doing any sort of chemical or sediment remediation type work. Some results of the hydrological studies from the Worley-Parsons report. This fella here estimated that annual inflow in the lake was 64% precip, 29% surface water inflow, 7% bedrock groundwater flow. At the time of that study, there were folks that were interested in potentially moving some water from the North Saskatchewan River, piping it to the lake to help flush it, or moving water from the Pascagoula into the lake and trying to stimulate water flows that way. Lake water levels are very sensitive to precipitation and evaporation. Lake water levels have historically fluctuated within about a 1 meter interval. And there's a weir at the outlet of the lake, and just the last year or so has started to spill, but prior to that, it didn't spill much at all. Historical water levels in meters above sea level at Pigeon Lake, measured from 72 to 2011. So there's a one stage station there. This is just the one station at the outflow of it. So we get almost real-time data on that. The outflow, so the weir is located at the southeast shore adjacent to Mamio Beach. It has quite a history to it, installed in '83 by ESRD with approval from the municipalities group and permitted for a height of 849.935 meters above sea level. There were some issues with that in 2008, some frost heaving. So it was brought back to that 849 in March this past year. So lake levels have continued to rise and recorded at 10 centimeters above the full supply level of 849.935. Water quality concerns. You either have to live out of province or be dead to not see some of the very graphic front page articles in the Edmonton Journal and the Calgary Herald from the persistent and kind of nasty algal blooms and some of the fish kills and those sort of things that this lake has experienced over the past few years. Persistent and prolific green algal blooms. Dr. Zerl will talk about some of the toxicity of those. The department studied this very closely. Lots of public health concerns regarding those toxins, lots of public health concerns regarding the coliforms in there as well. So beaches are posted quite regularly for fecal coliform numbers. I've talked to the environment minister or the health minister a couple of times about data accessibility and making sure that is communicated, but they do keep a website that's up to date with beach closures that we have around that lake. Significant fish kills in 2010 and again in 2012. And the conditions that mix together create a perfect storm for algal blooms. We've got high summer temperatures, creating water temperatures in the optimal range for algal growth, lots of bright sunshine, wind disturbance in the lake, algae grow well within the calm conditions. They mix in periods of high wind that recirculates our nutrients possibly from the bottom waters. And more phosphorus means more available nutrients for algae, which normally are phosphorus limited. So we've got a situation where a particular kind of algae can fix atmospheric nitrogen, and with an unlimited supply of phosphorus, outcompete the good phytoplankton, the good green algae, and these cyanobacterial producing algae get a competitive advantage in bloom. I believe, not just at Pigeon Lake, but I believe all over this province, that phosphorus is the biggest contaminant in our freshwater systems. It's responsible for a whole bunch of water quality problems. It's usually the limiting nutrient in freshwater systems, and primary factors contributing to the declining water quality: agriculture, residential developments, excessive nutrient inputs, in particular phosphorus. Phosphorus loading, major cause for algal blooms, reduced water quality, and declining fish, waterfowl, and vertebrate and plant habitat. And this is both from external and internal loading. I'm not going to get into the forms and fates of phosphorus, but certainly the kinds of phosphorus that we get coming into the lake is the kind, it's the inorganic kind that's immediately available for plant uptake. So the kind that we get from sewage or pesticide inputs that causes these explosive growths of plants. So sources of eutrophication: naturally occurring soils are naturally high in nutrients. So we live in the prairie pothole region. all the glaciers scraped all the topsoil from Quebec and Ontario here about 12,000 years ago. And we're sitting on, in some places, 80 to 100 meters of material. And that material is very naturally high in nutrients. We get these crazy water level fluctuations. It's dry, we're wet, we're dry. We're either, ask Lauren, we're either dealing with droughts or floods all the time. We have to be able to manage in those two extremes. Our lakes are no different. Natural shifts in aquatic community species. Atmospheric deposition, probably 50% of our phosphorus budget is going to be just from dust fall. And then of course we're exacerbating the situation ourselves. Agricultural runoff, feedlots, fertilizers, point source and non-point source, and of course the leaking septic systems. So we've got a history of cottage development. 50 years ago when we developed cottages around the lake, these were sort of set up for folks who are going to be around there for 2 or 3 months of the year. Now we've got 5,000 square foot palaces with folks living around there year round. So we're really stressing that lake out in terms of use. And what we were planning for 50 years ago is not the situation we have now. And that's no different from a lot of the lakes in the central part of the province. External sources of phosphorus, we are currently testing this, and this is sort of desktop phosphorus loading numbers for the lake. And again, I'm looking forward to, I hope we can hear from Alberta Lake Management Society and some of Chris's work on updating the phosphorus budget for the lake and what we've found thus far. So 16% of our phosphorus budget from the forested land, 30% ag, 14% residential. Desktop, ballpark, sewage is 2%, precipitation, dust fall 38%, for a total of 5,000 kilograms per year. And again, this is all good food for thought. Will be subject to some debate, I'm sure.
Changed a lot since 22.
So, internal loading, this is a situation fairly unique to Alberta. Sediment composition playing a crucial role in determining nutrient availability in lake water. This whole internal loading situation is one of the reasons why I came out to Alberta back in 1994. I was really fascinated by how phosphorus cycles and how this whole internal loading in lakes works. So I come from Ontario originally, and obviously we don't have internal loading issues in the shield lakes. Phosphorus binds to those clay particles and can be absorbed onto the sediments. Iron and aluminum also bind with it and precipitate it underwater, making it biologically unavailable. So that's why, of course, Dr. Schindler was working with doing iron, adding iron in some of our lakes to see if he could kickstart that complexing to have it bind more phosphorus out of the water column. Clay, iron, and aluminum concentrates in Pigeon Lake are not sufficient to limit the growth of algae plants. So internal releasing of phosphorus in sediments is likely a large contributor to nutrient levels within the lake. And this complexing, it's constantly going. So in the wintertime, you'll get anoxic conditions under the winter ice. That phosphorus will all release under those anoxic conditions. And then in the summertime, you'll get oxygen back down there, they'll recomplex and everything will rebind again. And then you'll get certain times throughout the summer, if the lake stratifies, if you get anoxic conditions at the bottom, you'll get the phosphorus decomplexing again. So you can get this cycle happening all throughout the summer at various times, and then throughout the winter, under winter ice cover, you'll find that strongly happening. And that's sort of like how wetlands behave in the prairies as well. We've mentioned lots of groups have been very active in sampling the lake. So there's been lots of water quality data collected historically through the U of A water quality sampling. OMS has done an enormous amount of work, the Alberta Lake Management Society, through the Lake Watch program, collecting water quality data at the lake. And then the department as well. So ESRD's, Word Environment and Sustainable Resource Development. 2006, we did some caffeine work. 2007, again, quality sampled it again. 2010, sampled by OMS, and then getting a nutrient budget going with a partnership between the department and OMS as well. What are we seeing? Large size, shallow depth results in mixing from the lake surface to the lake bottom. So if those anoxic conditions are happening at depth and the lake is well mixed, then the phosphorus that is released from those bottom sediments can easily make its way to the top of the water column. You've got sunshine, you've got warmer conditions, and you've got phosphorus. You've got a recipe for wild algal growth. So thermal stratification is not observed for the majority of the open water season, so we're not getting that strong stratification that we, if for an approach like a hydrolytic withdrawal that we saw at Pine Lake, you would need that sort of chemistry or physical limnology to happen. And we're not getting that at Pigeon, so that's not, might not be an approach that's very recommended, will be recommended for this lake. Steady trend towards increasing the water temperatures. And Ron will probably speak to that. I've seen some of his original research on how water temperature is a very effective predictor of our algal blooms in this province. The lake is well mixed throughout the open water season. No thermocline separating the warmer water from the near surface from colder water at greater depths. So that's usually what physically stratifies phosphorus from being able to come up from the bottom sediments. You've got that cold layer of water at the bottom that is not able to mix with the warmer stuff at the top. And that's not the case at Pigeon Lake. That's what some of this data shows. So seasonal low in June, 11 degrees, seasonal high of 19.38. And again, that seasonal high of 19.3 really gets into the prolific growth range for some algae. Dissolved oxygen relatively stable throughout the water column to a depth of 8 meters. The majority of the water column stays above the CCME guidelines for 6.5 for the protection of aquatic life for the most part. We may get oxygen deficiency at deeper depths that coincide with early June, likely due to decomposition and lack of mixing over the winter. And again, cyanobacterial blooms. So when those material, that algal material starts to die and the water column falls down the bottom, bacteria start eating that and use up the oxygen at the bottom of the water column. There are some pluses, of course, to being well mixed, though. In the dissolved oxygen case, obviously we're getting that good oxygen at the surface down to the bottom. So that's one sort of good thing for the aquatic life in the lake. Water clarity and Secchi disk depth. Resuspension of bottom sediments due to wind and boating plus high concentrations of algae in summer months results in low Secchi depths readings. So one of the physical limnological parameters that are collected under the Alberta Lake Management Plan's Lake Watch program is Secchi disk depths. So that's one of the first things we do when we zip out to these sites. Historical average for Secchi disk depths 2.24 meters. In 2013, average 3.2. Seasonal high of 5 in June, and the seasonal low, of course, when the algal gets blooming in August, really shortens up your water clarity, shortens up your depths. Cyanobacterial blooms. 2006 was our first and most severe recorded cyanobacterial bloom, dominated by Lingia, along with Eutrophication and Anabaena. Am I pronouncing those right? High concentration, I'm not a phycologist, self-proclaimed, not a phycologist. High concentrations of algae or cyanobacteria led to a blue-green algae advisory posted by Alberta Health Services on August 14th, later lifted on October 3rd. So that's a fairly long-lasting advisory. Microcystin levels have been historically low during blooms on the lake. However, it is impossible to measure neurotoxin levels without lab analysis. Dr. Zerlo, if there's any more information on that, on the cyanobacteria. So, Phanosomenon, Eutrophication, and Anabaena. So surface water quality, where are we? We certainly fall in that eutrophic range for total phosphorus, chlorophyll A, and TKN. 2013 average 26 micrograms per liter, chlorophyll A 12 micrograms per liter, TKN 785. And then our historical average is down below there. For surface water quality data, phosphorus is a primary nutrient of concern. So where are our phosphorus levels? 2013 we had a minimum 13 micrograms per liter, a maximum of 56 micrograms per liter, and an average of 27 micrograms per liter. I know our three experts at the back are thinking, that's not super crazy high level of phosphorus now, is it? Al's shaking his head no. Something that's puzzled me as well. So we're going to have some talk about that today.
You're going to have blue-green algal blooms at 20 micrograms per liter.
Yeah.
What do you dissolve phosphorus levels like?
Do we have dissolved
I've got,
phosphorus?
I'll be presenting that out.
Thanks, Chris. So total phosphorus and chlorophyll A track nicely as one would expect. 2013 surface water quality. Pigeon Lake is subject to large fluctuations in both total phosphorus and chlorophyll A. 2013 saw lower levels of total phosphorus and chlorophyll A and TKN compared to previous years. Why? Likely climatic factors, sunlight, temperature, precip. Despite the apparent increase in nuisance plume formation, both total phosphorus and chlorophyll A concentrations along with water clarity have remained relatively constant. So our results need to be considered in the context of sampling, which is consistent of whole lake composites over the euphotic zone over time versus localized areas near the shoreline. So that will be one of the criticisms of the data that we collect. A lot of the data that the Lake Watch program collects is 10 discrete sites from around the lake, which are composited. So they're not individual site collections. Our nutrient budget work. Sampling for the current nutrient budget began in 2012 with stream sampling carried out by Alberta Environment in partnership with OMS. My understanding is that is the first time any nutrient work's been done on the lake. Prior to that, it's all just been desktop, Pat Mitchell type analyses. The nutrient budget, yeah, it's all been desktop. So this is the first time we've actually gone out and measured it. So really excited about this work. 2013, the second year of this budget work, ESRD partnered with OMS. We increased sampling both stream and lake beginning in early May and running throughout October. So we want to get a consistent baseline data set. We really want to identify the major sources of nutrients coming in the lake and identify those areas of concern. And that'll really help us frame our conversation in terms of in-lake treatments as well. So nutrient budget, weekly lake sampling, weekly and bi-weekly stream sampling, doing some sediment core work for nutrient content, paleolimnological work, algal samples, and groundwater samples. So, and again, Chris is here from the department to present on that, some of that work. What are some of the next steps? We want to continue on with our watershed management planning and the development of the Pigeon Lake Watershed Management Plan, which is currently underway. Awful lot of development going on in our surrounding municipalities, and certainly their land use bylaws have an enormous effect and an impact on what goes on in this lake. So sewage, environmental reserves, setbacks, riparian management, all that strictly governed and run by municipalities, and obviously where they fall in the watershed management plan is extremely important. The engagement strategy has been developed. First two topics were chosen and worked through: cosmetic fertilizers and the model land use bylaw committees. Can't speak enough to that. Now all the policy folks in the room will understand how important those land use bylaws are in terms of how residential development and other development is going to continue to affect the lake. And again, we're seeing huge development in Leduc County and in Saskatchewan. Lots of cottage subdivisions being planned. Upcoming work includes engaging economic and agricultural communities, finalizing recommendations of the first two topics, and community consultations and identifying the next priority topics in regards to water quality. So lots and lots and lots going on, a lot of different players and a lot of different levels, from scientific work to municipal planning to provincial planning as well, land use framework, watershed planning and advisory council work with North Saskatchewan Watershed Alliance. So lots of balls at play, I guess. Next steps, further exploring options for the control of these blue-green algal blooms. 2012, Chris produced the lake and watershed management options for the control of nuisance blue-green algal blooms in Pigeon Lakes. If you haven't seen that document, make sure you let us know. We'll get you a copy of that. It outlined the potential control strategies for algal blooms, in particular, including a feasibility assessment outlining the benefits, disadvantages, and the applicability to Pigeon Lake, and included both watershed and in-lake control options. So looking forward to building on that work here today and tomorrow. Detailed sampling results from the nutrient budget can provide more insight into the feasibility of those current options. Some of the potential control methods for algal blooms, and like I said, there's nothing that's off the table right now. We want to have a full and engaged talk about all of the things we can do. We've got some very knowledgeable people on worldwide experts on all of these different options that we can look at, but things like circulation and destratification, dilution and flushing, dredging, wet excavation, hydraulic removal, mechanical removal, sonication, oxidants, phosphorus inactivation from a whole variety of techniques, sediment oxidation, settling agents such as alum, other biological manipulation, i.e. enhanced grazing. One of the things Dave Schindler had proposed was trophic cascade through enhancing top-level predators in the lake. Talked about that, pathogens, and lots of different control methods for algal blooms that we've seen throughout North America and the world. Physical in-lake controls, physically modifying the lake water column or basin, removing the accumulated nutrients, disrupting the favorable conditions. In the in-lake treatment controls, adding chemicals to kill algae or reduce nutrient levels available for uptake, or biomanipulation, alteration of the lake ecosystem to promote less favorable conditions for the growth of algae. Limitations, we'll get into these in day 2, but certainly we want to keep in mind expenses, the size of this lake. An awful lot of things, an awful lot of treatment methods have been proposed for the lake, and we need to realize this is not a small stormwater pond. So we've got a very large freshwater system that we're dealing with here. There are uncertain long and short-term ecological impacts that may likely cause other unexpected effects, which may be undesirable. I've been dealing quite a bit with the Alberta Invasive Species Project team, and we introduced fish to take out the zebra mussels in the Great Lakes, and now the fish that we introduced into the zebra mussels to take care of the zebra mussels are now themselves a problem. So we need to be aware of the other downstream effects that we can have as well. Regulatory approval could be difficult for certain methods, procedures, or approaches, and again, these will all need to be socially acceptable as well. This is a very heavily used recreational lake. Harry Gibbons and Terry McNabb will be presenting on in-lake treatment options in greater detail. Groundwater overview. Worley Parsons conducted this hydrological assessment of the lake to assess the groundwater interactions in the area. Again, they really wanted to focus on moving water, see if it was feasible to move water from the North Saskatchewan River or groundwater from the Pacific. The following slides are a brief overview of some of their results from that report. Their study did not address the quantity of water needed for ecological maintenance of the lake or for sources of water diversion, so they didn't get into that specifically. Where is their groundwater wells? They dug through the well water database. They found almost 3,000 wells in the basin, 90% of those domestic, 10% industrial and municipal for irrigation. The majority of those were shallow and were located in the drift or upper part of the bedrock. There are regional groundwater monitoring wells located to the northwest and south of the watershed, and they plotted those against lake water levels. They found the shallow aquifers had a hydraulic connection with the lake levels, but the deeper ones had little or no correlation to lake water levels. So the results suggested that hydraulic continuity with the upper drift and bedrock aquifers, or that water levels in both the lake and upper aquifers are influenced by similar functions like climate or precip. Bedrock geology of the lake. Air surface bedrock below Pigeon Lake is located in the Paskapoo. The base of groundwater protection, or depth to non-saline groundwater, is approximately 240 mdgs beneath the Pigeon Lake area. Near surface bedrock below the lake contains interbedded mudstone, siltstone, and sandstone, fossiliferous limestone coal, and bentonic beds. So primarily thick, medium, coarse-grained sandstone units in the Paskapoo region there. And that study has now been released as well from the province. It's a great big groundwater atlas book for the Edmonton to Calgary corridor that this was part of. Bedrock geology. Thickness of the Paskapoo is about 80 meters. Sediments lie above the bedrock surface in varying thickness and age. There's movement of groundwater through the sediments depending on the grain size and the permeability. And those drift deposits range from 3 to 40 meters overlaying bedrock in the Pigeon Lake area. The deposits are composed mostly till, glacial fluvial deposits, and glacial lacustrine deposits. So again, material was dragged here from eastern parts of Canada and deposited through the last glaciation. Pigeon Lake Groundwater Systems, 3 flow systems contribute to groundwater sources. The local system with drift deposits, influenced by local topography and short-term precip. The upper bedrock system, so that upper 30 meters of the Paskapoo, was influenced by larger scale topography and longer term climatic influences, and then the lower bedrock system. And I know Dr. Kathy Ryan from the University of Calgary has also done quite a bit of work in and around the Pigeon Lake groundwater. So groundwater yields, sandstone units contain the best aquifers, and they had some fairly high yielding flows. However, the study suggested that water yield from the Paskapoo would provide less than 1/10 of the desired diversion, so they ran some numbers and figured that we need a better flow rate, something from the North Saskatchewan River would need a better route to go. If groundwater is further to be considered as a possible source of supplementary water to the lake, they suggested detailed investigations pertaining to sustainability of that lower Paskapoo would be required. And I don't believe that work is ever undertaken or followed up on. They also found that water quality could have been a limiting factor as well. We might not want to use that water, but certainly wanted to pay attention to total dissolved solids and hardness in the groundwater quality and the impact it might have on the freshwater, surface water. 2 main groundwater types were located in the area: calcium or magnesium bicarbonate waters associated with the drift deposits, and then the sodium bicarbonate water associated with bedrock. Water quality was considered to be good. Components of the Paskapoo do not typically react with water, therefore less are dissolved when compared to water moving through the sediments which lie above bedrock. Some data gaps and next steps from that report. Groundwater sustainability needs to be more closely examined, including current domestic and agricultural groundwater usage and ecosystem function. Water quality from the Paskapoo needs to be further characterized in greater detail. 12 groundwater samples were taken from various sub-watersheds around the lake in October. We looked at orthophosphate, total dissolved phosphorus, TKN, nitrate, total dissolved solids, TSS, dissolved organic carbon, total organic carbon. And Chris will be elaborating on these results during his part. So further groundwater studies are going to be taking place again in 2014. One of the things that we want to set as a goal: what is the goal for the desired outcome? How do we measure success for Pigeon Lake? Are we looking at recommended days that it's closed? Is it a certain phosphorus concentration that we're going to decrease? I know for Al, I'm going to steal any of your thunder, but for the Pine Lake folks, it was a return to 1900. So we wanted to have the phosphorus levels in the sediment in the 1900 levels. We wanted to return to those levels, what we'd see in the overlying water quality. So that's something for this group to be thinking about, because that'll be one of the first activities that we'll do after we hear from the experts. So without further ado, it's 10 o'clock now. We'll have a short coffee break, and then I'll bring us back, and we will start to hear from more on the background of the lake itself from Chris, cyanobacteria from Ron. Al Sosiak will introduce us to the Pine Lake Restoration Project. So a lake right nearby to Pigeon Lake, similar water quality and algal problems. Harry Gibbons will talk to us about how to manage your lake eutrophication, and then we'll wind up our day with talk from Terry on in-lake treatment strategies, so his experience over the past 40 years. Yes, Aaron.
Does anyone have any questions for Jay before we get all excited about coffee?
Yes, Al.
What do we know about what's causing the fish kills?
I'll be talking to that a bit.
Okay.
Yeah.
Talk about it.
Yeah. And if it uncovered, then we've got 2 fisheries guys here.
No pressure.
Yeah.